हेलो दोस्तों। टुडे वी विल डिस्कस अबाउट प्रेजेंटेशन ऑन डिस्टिलेशन कॉलम। इन दिस वीडियो we will study about distillation column and its types and its schematic. What are the different sections like stripping section, rectifying section, and fundamental behind distillation. It is like the heating of the liquid solution of two or more than two components or gaseous mixture. Right? So basically, it is a separation technique. So in this way, we'll study about distillation column in this video. Right? So I'm starting. Mm. So, so hello everyone. I'm Hemant Kumar Nayak, and we are going to present presentation on distillation column, right, for our CFA training center. Yes. So first is uh, what is distillation? First, we have to know what is distillation. So distillation is a process by which we can separate mixture of different component, right, by applying heat and separation of component in section and desired protein. We have desired by application and removal of heat, right? So distillation is based on the fact that the vapor of a boiling mixture will be richer in the component that have lower boiling point, right? So based on boiling point, so if a component have less boiling point, right, so it will vaporize fast, right? And based on that boiling point, we can separate different component. So these are basically the definition of distillation by heating the sample based on boiling point. We can separate the components. So basically, distillation is the most common separation technique, right? Distillation is a separation technique, as we all know. It consumes enormous amount of energy, right? It consumes enormous amount of energy, like you can see in this. The heating is provided so that mixture will boil, both in terms of cooling and heating requirement, right? So after heating, we have to cool also to condense the vapor. And so in this way, we need energy in distillation. So it will consume lot of enormous amount of energy. And so now types of distillation column. So this picture is a distillation column, right? In the industry, in chemical industry or petrochemical industry, we can see the distillation, typical distillation column. It looks like this, right? So there are many types of distillation column, right? So, but basically we define like batch and continuous column, right? Batch and continuous column. And so, another other way to classify distillation column is uh, batch and distillation, batch and continuous, right? So, and after that, uh, we can define another types of column as well, right? So, we have batch and continuous columns. And in batch columns, basically we look in this batch operation will be there. Feed to the column is introduced batch wise. Right? Batch wise, we have to introduce the feed into the column, and the column is charged with the batch, and then the distillation process is carried out. And simply, whatever we are going to feed the sample, we insert in a batch wise, right? Batch wise, and when the desired task is achieved, the next batch is feed to the introduce. So whatever we feed, once this is completely separated, then another batch of the sample we have to feed. And so this is batch wise column, and in continuous column, uh, continuous column process is continuous, right? We can directly feed to the same components into the distillation column, and again it is means continuous process. No interruptions occur unless there is a problem with the column or surrounding process unit. As continuously we uh, we run the process, and no interruption will be there in during the separation process. So they are capable of handling high throughputs and are most common of two types. Right? So now components of distillation. What are the main components of distillation column? So distillation column are made up of several components. Each of which we use either to transfer heat energy or enhance mass transfer. Right? In this distillation, mass transfer and heat transfer take place. Uh, right. So a typical distillation contains several major components, right? So distillation component contains several major components. First, a vertical cell. A vertical cell where the separation of liquid component is carried out. And then column internals such as trays, plates, right? So in between the certain trays or plates will be provided. A bubble cap type valve, a sieve plate type, different type of uh, plates are there, or packing. Sometimes packing also will be provided, which are used to enhance the component separation, right? So to increase the separation, packings will be provided. A reboiler to provide the necessary vaporization for the distillation. In the bottom section of the distillation column, one reboiler is provided, right, so for the heating purpose. And then in the top section, condenser will be there to cool the condensate, the vapor, whatever vapor is going out, we have to condense that vapor. So we say that it is condensate, leaving the top of the column. And then next is reflux drum. One reflux drum is there to hold the condensed vapor. And whatever condensed vapor is there, we have to hold the condensate so that uh, we can now from the reflux drum, we can separate top product, right? And some amount of liquid is again fed to the distillation column, that is reflux, can be recycled back to the column. So again we have to recycle the condensate in reflux section. So this is the component of distillation column. This schematic is basically the distillation process. How the means different section will be there. Feed we have to uh, supply feed in this middle of the distillation column, and the above is enriching or rectification section, and the bottom one is stripping section. Right, so different trays will be there. Number of trays will be there. And so this is condenser in the top of the column, and this is reflux drum, and some part is again recycled, so the reflux will be there. And the top product is distillate. We say that distillate. So in the bottom section, a reboiler will be there to vaporize the sample. And so and in this heat is supplied and heat is out. Right. So, and the bottom product, whatever is there, we say bottom product or residue also, terms residue. So, and the terminology, basic operation and terminology. What are the terms used in the distillation column? So basically, heat is supplied to the reboiler to generate vapor. So heat is supplied in the boiler to generate vapor. So we heat the mixture to vaporize. And so the source of heat input can be any suitable fluid. Right? Source input will be any suitable fluid. Although in most chemical plant, this is normally steam, right? So most chemical plant we heat through the steam. And the liquid removed from the reboiler is known as the bottom product and simply bottoms. So these are there. The vapor moves up the column. The whatever vapor will be move up of the column. Right? And it exists the top of the unit. Right? The top of the unit will be there. It is cooled by condenser. The vapor will be cooled by condenser. And the condensed liquid is stored in a holding vessel known as reflux drum. Right? One reflux drum is there to hold the condensed liquid. Some of this liquid is recycled back to the top of the column, and this is called the reflux, right? So already I have explained. Now, the condensed liquid that is removed from the system is known as the distillate or top product. Okay, so the top product is known as distillate. So some amount of the condensate is recycled back, and the top product is collected, and it is known as distillate. And so these are the term used in the distillation column. So we can see the multi-stage binary distillation column, right? The multi-stage binary distillation column. Why we are saying multi-stage? Because the different traces are there, right? And the binary means a two-component mixture. Two-component mixture basically like benzene, toluene, right? Yeah, methanol, ethanol. This type of two mixture solution. That's why it is multi-stage binary distillation column. Different traces will be there inside the column. Right. So, and the above feed section, we say that rectify section, and below is known as stripping section. Right. So, in this, you can see reboiler in bottom and the condenser is top. We can see the schematic of the typical multi-stage binary distillation column. Yes, so, I have already explained to you in the previous slides. And the description of the process, whatever phenomena happen in the distillation column. Again, we are studying this. And so what happens first, the feed containing the component to be separated enters around the middle of the column, right? In the middle of the column, we enters the feed, we call it a feed. It will enter in the middle of the column. The feed can be in any state from a cold liquid to superheated vapor, right? And different type of feed will be there. Cold liquid or superheated, saturated, different type of feed quality is there. So it will be cold, subcooled, superheated, saturated vapor. Right. So these are the feed condition, and the liquid and vapor are in counter current contact throughout the column as the liquid flows down and the vapor flows up the column. Right. So counter current will be there because the liquid will flow down and the vapor goes up. So it will be counter current. Right. So at each distillation stage, some of the vapor moving up the column is condensed, and this in turn evaporates some of the liquid. Right. So because uh, heat transfer is uh, every section, means every stage heat transfer will be there because the means hotter and cold liquid. So from high temperature to low temperature, heat will be transferred. So this in every section of the column, heat transfer will take place. If there are two components in the feed, then a greater amount of the less volatile component will be condensed. Right? So less volatile means its boiling point is high, and more volatile means its boiling point is less. So more volatile component will first reach the top of the section, and the less volatile component will go bottom. Means because its boiling point is less. So in this way, we can separate in the distillation column based on their volatility. Like means volatility is related to boiling point. Right. So these are the processes involved in the distillation column. And the rectifying section is the name given to the stages above the feed. Above the feed, the rectifying section, right, where the concentration of the more volatile component increases in both the liquid and the vapor. The concentration of the more volatile component increases in the both liquid and the vapor. And the stripping section is uh, in the stripping section is the name given to the stages below the feed point, right? Below feed point stripping section, where the concentration of the more volatile component decreases in both liquid and the vapor. Concentration of the more volatile component decreases in the both liquid and the vapor. Right? So the overhead vapor containing the most volatile component from the feed moves from the top of the column to the condenser. In this heat exchanger, cooling water is used to condense the vapor to liquid, right? So cooling water will be used in the heat exchanger to cool the vapor, condense the vapor, right? The liquid from the condenser is split into two parts. First, the reflux is fed back to the column, where it moves down the column in counter current flow with the vapor flowing off the column. Right? The overhead product contain liquid with a composition is specified in the design of the column. The ratio of the reflux flow rate to the overhead product flow rate is called the reflux ratio, right? So reflux ratio is basically L by D, right? So the means whatever reflux is there and the top product is there. So its ratio is very reflux by top product is known as reflux means is known as the reflux ratio. हाँ पीपीटी है भाई।
तो इसको क्या, ये तो पीपीटी बनाया ऐसे?
हाँ अभी मतलब अभी ऐसी कंटेंट कर क्या हूँ यार, तो जो जो थोड़ा सुधारना है सुधारूंगा, यही हाँ?
मैंने देखा नहीं यार।
नहीं देखो ना भाई,
देखना होगा।
अभी थोड़ा सा करना पड़ेगा, कंटेंट किया हूँ, कुछ कुछ उसमें सुधार
ये
करना
तो
है।
खुद के पढ़ने के लिए है कि तूने पीपीटी ही ऐसी बनाई है?
अभी भाई इसको अभी ऐसी बनाया है, उसको कुछ कुछ जो करना है, मतलब सुधार करना है यार इसलिए, हाँ। जो जो मिला था ना कंटेंट, उसको मैं इसमें कर किया हूँ। The ratio of the reflux flow rate to the overhead product flow, called the reflux ratio, and is an important parameter in the design and the operation of any distillation column. Now, the bottom liquid containing the least volatile component in the fluid flows from the base of the column to the reboiler. In this heat exchanger, steam is used. So, in the reboiler, steam is used to vaporize some of the liquid which flows back up the column in counter current flow with the liquid moving down the column. The amount of heat paid to the reboiler determines the vapor flow of the column. If, in reboiler, steam is there to heat the uh, less volatile component. Right. The bottom product has a specified composition fixed during the design of the column, and a second product is streamed from a distillation column. Hmm. So now distillation principle. So separation of component from a liquid mixture while distillation depend on the differences in boiling point of the individual component. Right. So based on different boiling difference in boiling point, we can separate the component. Also depending on the concentrations of the component present, the liquid mixture will have different boiling point characteristic. Right. Therefore, distillation process depend on the vapor pressure characteristics of liquid mixture. Vapor pressure is also important in case of distillation. So the vapor pressure of a liquid at a particular temperature is the equilibrium pressure exerted by molecules leaving and entering the liquid surface. Yes, this the liquid is said to boil when its vapor pressure equals the surrounding pressure. Right. So whatever vapor pressure is equal to surrounding pressure, then liquid will start to boil. This is boil, and the ease with which a liquid to boil depend on the volatility. So based on its volatility, uh, any liquid boils depend on its volatility. With the high vapor pressure, volatile liquid will boil at a lower temperature, right? So high volatile liquid will boil at lower temperature, means its boiling point is less uh, because of the differences in the volatility of the component in the liquid mixture. Yeah. Then the relative volatility. The relative volatility, right? So relative volatility is a measure of the differences in volatility between two components. Right? So two components will be there. Their volatility is different because of their boiling point. So it indicates how easy a difficult or particular separation will be. Right? So if the boiling point is less, then it will easily evaporate. Means fast vapor will be first comes of higher, means less boiling point component will start to boil fast, and so it will go up easily, means fast, and after that the high boiling point component will be price. Thus, if the relative volatility between two components is very close to one, it is an indication that they have very similar vapor pressure characteristic. And so if relative volatility is close to one, then its vapor pressure are same. Right? So this means that they have very similar boiling point, and therefore it will be difficult to separate the two component via distillation. Right? So if relative volatility is close to one, means the component have similar boiling point, then we cannot able to separate in distillation. All right. So these are the main point we have to take care when we are going to separate via distillation. And so these are the references which I have used to make my presentation. And thank you guys for being here. Thank you. Nice day. Good night. Bye.